All right, here's a quick demo of our scrollback compression in Ghostty. I'm going to show you the demo, then I'm going to explain what's happening. So let's fill up our scrollback history. This is a debug build, so it's a little bit slower. You can see as data's coming in, we're getting some compression down here. It's done. So we created 25 megabytes of scrollback in Ghostty currently, the release version, and at the time of recording this, the nightly version. This is how much RAM this would actually take. But in this upcoming feature, we now compress as much as we can. Basically, what we're not looking at, we compress, and we go down to now 2 megabytes, which is about 90% savings. As we scroll, you can see we do decompression as needed, and the decompression is fast enough that we could pretty much scroll at full speed here and see no hiccups whatsoever. And also, I don't know if you noticed, but while I'm scrolling, you could see if you look at those stats down there that there's about half compressed. And then when I let go, it eventually compresses. That shows another sort of feature of this, which is that we do compression when we detect idle states. So this doesn't affect I/O throughput at all. Under really heavy I/O, we will balloon memory in order to preserve I/O performance. But then when we hit an idle period, which currently is 250 milliseconds, but we'll empirically sort of watch that. But when we hit that idle period, then we start doing compression. A really cool point about this too is the compression is incremental. So after we hit that idle period, we do a small, cheap incremental compression pass, and then check if there's more I/O that if we need to stop compressing. And so if we basically scroll really fast and decompress most, let go, and then keep going, it could actually still be very responsive to everything in I/O and the UI, which is really cool. So effectively, what this is gonna cause is a huge amount of memory savings. I I don't know if any other terminal does this. A quick Google didn't pull up anything, but I'm not sure how much people would talk about it. This might be unique to Ghosty. I'm not sure, but it's certainly going to save a whole lot of memory because text is very compressible. As you can see here, we're already getting pretty good compression, and this is a pretty naive LZ4 compression algorithm that we're using here. And the other thing that's kind of interesting, just some background on this, is what we're doing with the memory here. So we're using a couple features from Linux and Mac OS, a couple low-level system call flags from Linux and Mac OS, so that when we compress the memory here, we're keeping the virtual memory allocations, but only discarding the resident memory, or telling the OS that they could discard the resident memory. The actual detail there is Linux actually discards it. Mac OS will under memory pressure, but doesn't by default. It just knows that it can discard it. And basically, what that means is that when we restore, when we decompress, the decompression is can't fail. We already have the OS has already promised us that that memory exists for us to use. It's already sort of there in virtual memory, and we have the address, we have the length given to us. So once we touch and reuse that memory, then the operating system, pages in the actual physical memory and figures out what it needs to do. Just like a cool, neat little detail here. But yeah, this is compression. This is sort of a first pass at it. I'm really excited about it. It's going to save a ton of memory for people, and this will be coming out soon.